Hello and welcome. So this is our example 2 that we are going to cover in this video. So example 2, the text I will read and then I will start the ladder logic programming. The text is, the problem is a certain switch, we name it switch 1, is to start a process. The process can be anything or it may be messy. The process is to run for 30 seconds, stop for 10 seconds. And then repeat this 10-second and 30-second cycle. 30-second run, 10-second stop, as long as the switch 1 remain closed. Closed means it is on, is connected. Now opening the switch 1, like breaking the circuit of switch 1 at any time, will reset all the timers, de-energize all the outputs. So now we have covered two sentences. One sentence, it says there is one process that will start after closing switch 1, and the process is 30-second run, 10-second off, on and off, as long as switch 1 is closed. Now output is to be energized during 30-second run period, and output 2 is to be energized during 10-second stop period. So there is three things involved. We are starting a process. The process doesn't have any output involved in it, but when the process is running, output 1 is energized for 30-second run period. Output 2 is energized for 10-second stop period. So we have two output identified from this problem, and one switch we have identified, and two timer. One timer will run for 30 seconds and the timer will run for 10 seconds. So as far as this problem goes, we have one input, two output, two timers, and one general process is going to run and stop. So let's go to the problem, and we declared some variable for that. What we can do before declaring any variable, let's create a problem, a function block for this. Add an object in code says, right click on application folder, go to add object, POU, programmable organization unit, program organization unit, and then select the function block. We can name it a process. And we choose the language ladder. Alright, so we have input, that is start input or switch. We give exact same name, switch 1, and just like in the program it is mentioned switch 1, and then we have output 1 and output 2. So variable output we declared output 1, output 2, but the thing is we have to now define it as a boolean semicolon, this is output, so we don't have to initialize. We can, but we don't need to. Then bool, here we have to initialize something like false. Actually we shouldn't initialize the input variable, that's defined. And then we have a process as a input and output variable. this is output. So we have another in out, and in out is having one output. We call it process. So that's it. What other problem we have? We do not have problems. Let's look at it. If we build it, we will come to know if it is having any problem. No, no problem. Maybe dash is not good idea. We give it underscore. Okay, so thing is like that. We have one more thing to declare, is the static variable. So you have to. Okay, so static variable stat. In the variable stat, we have to define two timer. One is T1, which is 30 second. What timer we have it? Okay, so we have T on, that is type T on, and then we have T2, this is also T on type. Okay, let's save. Okay, we have saved the variable declaration, and it's successful without any error. So now we can simply start the programming, ladder logic programming. We have to start from the switch. Here is the few of the digital boolean instruction. On the right side, the ladder logic, all other function and instruction are available. Math, boolean. Okay, so you can pick up from either on the right side ladder element, or from here select the run and then choose contact and drag and drop. And here you can click and then pick up the switch. Okay, then when the switch is closed, we start a timer. Actually, we start a process. So the process is, it says directly when switch is on, we start the process, right? Opening the switch at any time, reset all the timer, de-energize all the output. So actually process stops. Process is to run for 30 seconds and stop first. So process is going to run. It's going to uh, run the process when the switch is on. So we have to do. Let's latch the output a bit called this one. Insert set. So we're going to start a process when this is closed. So this is in out. Argument it is not specified. Okay, so let's create another network below. When this is on, this process is on, we are starting a timer T1, and the T1 we give T1 this one, and 30 second is T 30 second. 30 second. Okay, and then when process is on, and then process is going to reset for 10 second. So this is going to be set for 30 second, and then we are going to start a timer. When 30 second passed, then what we can do is we actually turn on the output as well, parallel to this one. What we can do is another way. We have to prevent this. We can actually insert a coil instead of set reset. We give a coil here, and that process. Okay, so when this is running, T1 oops, switch 1 is on. This one is going to start when T2 is not on. T2 dot Q is not on. Okay, another network we can use down below. Copy this, paste here, and here we're going to use T1, and T1 is not on. So T1 is not on. That means 10 seconds, and this is going to be T2. When T2 is not on, we start T1 30 seconds. When this one is on, we start another timer, and when this turns on, our first timer restarts, because when it turns on actually it becomes false, so this resets the T1. We can delete this by delete command or unused MP call. We can do here as well. Now main thing is happening here. So when our first 30 seconds we want the process to run, uh, then only we allow this to be on. So we give here this one T1 queue, because first 30 seconds is off, so process is on, and the next 10 seconds this is going to be on, so the process is going to be off. So that's our logic for the process. Now as far as output is concerned, output, now we can actually use this same bit to turn on and off this bit. We can also actually use the coil here directly. For the first 30 seconds we want the output to be on. As not that way actually. I think we use the other one first, because this timer output will remain on for how long? Output will remain on for only 10 seconds, because after that another timer will start, and then after 10 seconds this will get reset. So output of this timer will be on for 10 seconds, and output of this timer will be on for only one scan. Yes, only one scan, because once it is turned on, in the next scan this will be 0, and output of this will get reset. As long as it resets its output, this is going to reset, and next is output. So only one scan, so what we have to use this input. Let's use this process. When the process is on, we turn on the output. One else we do not have any negative instruction here. Not negate contact. Okay, anyway we use different network for that. Copy and then paste. We have to use the other negation of this, and then use the output 2, and that is for 10 seconds. So this is the all program for this example. Switch 1 will start the process, and the process is going to run for 10 seconds and stop for 30 seconds and stop for 10 seconds, and then 30 second output 1 and 10 second output 2 will be energization timing. Opening switch 1 will reset the timer and reset the output, and that is what we're going to do right now. Okay, so next thing in this example pending, we can say is opening switch 1 at any time is to reset all timers and de-energize all the output. So that is pending in our case. What is that? Okay. So if we open the switch 1, process will obviously stop, but the timer is freewheeling timer. So here we have to add this one, or you can just copy and use in all the networks. So now what will happen when we open the switch 1, it will reset the timer as well as the output. So that's the example completed, the ladder logic. The next work we are going to do is call this MD process into the program block. We open the program block and we have to call in new network, insert box, open input assistant, application, process. So this is the process. We have to give some name. Okay, give the default process underscore 0, process program variable scope. Okay, so we accepted all, and we have to define some variable for this. We give some name like example2 variable, and then where switch1 bool false. So this is the one we need, and then for output we need two more variable. Output underscore 1, output underscore 2, and that's all. Switch 1 into switch 1, output 1 into output 1, and then output 2 into output 2, and then process something we can actually remove. We don't need here. It is there. Okay, let's see if it is giving any error. Yes. So it says in our process must be assigned. Okay, so we give some variable process. Okay, build, and then we're going to simulate this. Online, login, download. Start simulation. Switch 1. We're going to start this process. Okay, so the process has started. We're going to see 30 second and 10 second on off period. Output 1 is on because the process 1 is 1. The process is 1. So after that much time, 30 seconds, this is going to be on and this is going to be off. We're going to see that. Let's go to process and see the timing. You want elapsed time 30 seconds. Process is off now. Process is off. Yes, now it was off and then returned another. So this is going to work that way. So our T1 is running 10 second, 11 second, 12. It will run for 30 second and then the timer 2 will start for 10 second. Now 21. We're going to see the switch between these two output. Status is now going to on the output 2. Yeah, so it's going to run for 10 second. T2 is started 5 second. So another 5 second and then it will turn on output 1. Yes, so this is working. Now function is if we turn off the switch 1, open the switch 1, the whole thing will turn off. Let's do that. Okay, so everything turn off, process, output, as well as the timer. That's good. We have completed the example 2. Then there is extension to example 2. We will do in another episode. Thank you.